Welcome to the subject of microcontroller. This is Professor Meenakshi Panchal from Electronics and Telecommunication Department, Parvatibai, Gyanba Mujhe College of Engineering, Wagoli, Pune. So in this lecture, we will going to study about memory organization of 8051 microcontroller. The figure shows the memory organization of 8051 microcontroller. The first figure shows the basic memory structure of the microcontroller 8051. This memory can access up to 64 kilobyte of program memory and 64 kilobyte of the data memory. It has a 4 kilobyte of internal program memory and 256 byte of internal data memory. Each memory has separate addressing mechanism, so it has also different control signal and different functions. Each memory will be used the same address and data bus, but with different control signals. Here the figure shows the upper figure shows the memory organization of 8051 microcontroller. In this microcontroller, the up to 64 kilobyte of the program memory and 64 kilobyte of data memory you can access separately, and 4 kilobyte of internal program memory and 256 byte of internal data memory is there. Here, this is the internal memory. This is the internal memory, and this one is the external memory. This is program memory, and this is one is a data memory. Here, this one is a program memory, and this one is data memory. And here, these are external memories. Each memory has separate addressing mechanisms. All the memories have a separate memory mechanism and same data and address bus. The same for transferring and exchanging the data, same bus will be used, but the control signals are different. According to the control signal, the bus may be used. It may be used for the data or it may be used for the address transfer. First, see one by one what are the program memory here. The 80 microcontroller 8051 has the 64 kilobyte of external and 64 kilobyte of internal program memory here. In this program memory, 60 kilobyte of the internal and 64 kilobyte of the external program memory is there. And here this program memory. Here the program memory, this figure shows the program memory. In this program memory, have 60 kilobyte of the internal memory and 60 kilobyte of the external memory. These two memories are separate here. If the pin is connected to VCC, which pin? If the pin if the pin PSEN, is connected to VCC, then the program fetches the address from 000H to 0FF are directed to internal memory and the address from 100 to FFH for the external memory. These are the addresses here. This is the program address memory 000H starting from 20FFH. This is the address of internal program memory and 100H to FFFH. This is the address of external memory, external program memory. So total address is from 00H to FFF. These include internal and external memory both. In this, if the signal is activated, the output enable signal from ROM and EEPROM. Here, same in the data memory. 8051 microcontroller has which can address up to 64 kilobyte of the data memory and 256 byte of the internal data memory. 64 kilobyte of external memory and 64 kilobyte of the external memory. And 256 byte of the internal data memory. This figure shows the memory map of the 8051 data memory. How we can going to fetch the data from this data memory by using MOVEX instructions. The instruction MOVEX is used to access the external data memory and internal data memory space is divided into three blocks. Lower 128 byte and 00H2 7FH and upper 128 bytes. And the SFR, the upper 128 bytes, and SFR occupies the same block of the address space through the separate. Say here, the internal space is divided into three blocks. The internal space memory is divided into three blocks here. Here, 1, 2, 3 blocks is here. So from 0 to 7FH, this one is other, which is called as accessible by direct or indirect addressing. And from 80H to FFH up to here, use these memories used for special function register. This memory is used for special function register. I'm right here. Yeah. The address space from 80H to FFH and the SFR special function registers are used. The same upper 128 byte of and bytes and SFRs occupies the same block of the address space. These both are occupies the same block for the address space. This is accessible for indirect addressing. This is accessible by the direct addressing, and this is accessible by the direct addressing. Especially SFRs are occupies in this space. But although both are different blocks, but these two both are the different blocks. So this is the internal memory organization. How the memory will be organized. You can see in this slide. The upper portion of the computer system, the system should have memory for the program code. Then the memory for the program code is normally is called as a ROM. The 8051 microcontroller has internal RAM and ROM both. If the memory is sufficient, then the additional insufficient, then memory externally added to using the suitable. Here, for the upper operations, for the proper operation of the computer, if the computer should be operated proper, there should be a memory. There are two memory, program memory, data memory. Here the memory, there but there should be a particular memory. Memory is for code memory, program code memory, and that code memory is normally stored in a ROM. That code memory is normally stored in ROM, and the 8051 microcontroller has an internal RAM and ROM, which is having both the RAM and ROM. And if this RAM and ROM is not sufficient for a particular circuitry or particular application, then what should do? Then external memory can be interfaced with our 8051 microcontroller. So the 8051 microcontroller totally has 128 byte of internal RAM. 128 byte of internal RAM. And this internal RAM is organized in three distinct areas. This internal ROM is RAM. This internal RAM is organized in three distinct areas. Yeah, three distinct areas. The four registered bank of 8 byte each. In first area, there are four registered bank. Bank 0, bank 1, bank 2, and bank 3. And bit addressable area of 16 byte. This is 16 byte bit addressable area. These are this is first area which is having four register banks called B0, B1, B2 and B3, and second one is 16-bit bit addressable area, and third one is general purpose RAM area, or which can also called as scratchpad area. And the figure shows the internal RAM structure with the memory map. This whole figure shows this memory map of the all internal RAM of the 8051 microcontroller. So first we see how the register banks are organized in a memory. There are total 4 register bank of 8 byte each. There are 4 register bank 8 byte each, and the number is from 0 to 3 in 128 byte RAM of 8051. Each bank is made up of 8 registers named as R0 to R7. Each register bank is made up of registers which is having name from R0, R0, R1, like this one is named like this, R2, R3, R4, R5, R6, R7. Yeah. Like this, particularly each bank have named like this. The bank 0, which is having address from 00H to 07H, which is having total 8 register named from R0, R1, R2 to R7. Then total the same kind of organization having these registers, the register bank also. So totally there are 8 register. This is also having 8 register, and total this is having 8 register, and this one is having 8 register. So totally how much register is there? 4 into 8, totally 32. 32 byte, 32 working registers. The register bank are organized like this. There are total 4 register bank, bank 0, bank 1, bank 2 and bank 3. Each register bank having 8 register. Each one is 8 byte. 8 byte, 8 register is there. Starting from R0 to R7. Same organizations are have these remaining registers also. This is also having R0 to R7, R0 to R7, R0 to R7 names like this. And total 8 into 4, there are total 32 working register are present in these register banks. Total. And the total address of the register bank is from 00 to 17F. This is the starting address of the registered bank from 00H to 1FH. This here name given 00 to 1FH. This is the starting address of the register 00H to 1FH organized in 4 registers. The RAM location 00H to 07H are set aside for the bank 0. That's name of register is R0 to R7, and R0 is a RAM location where 00H of R1 is RAM location 0H1 and RAM location 0H2 02H as well. The second bank of the register begin at 08H. Here the second bank. This one is second bank. Here this is second bank is begin from 08H to 0FH. This is 0FH. And the third bank of the register is R0 to R7 begin from 1 10H to 17H. And finally the fourth bank of the register is finally this one is starting from 18H to 1FH as shown in the figure. Before selecting a registered bank 2 bits, how we can going to select this registered bank? How we are going to select this registered bank for particular operation? Here. We are going to select the operations of this particular bank by using the register PSW. This is the register PSW. This is the register PSW. PSW program status was here, which is starting from 0. Is starting from 0 and end address is 7. The bit address of PSW 0, 1, 2, 3 and 4. This is 3 and this one is 4. By setting these two bit, the bank registered bank, which bank is going to select is decided by using these two bits. If this is selected 0, 0, the PSW 0, PSW dot 3 and dot 4 by using these two registers. If this one is 0, this one is 0, then bank 0 will going to select. If this one is 1, if this one is 1 and this one is 0, then 0, 1. 0 when bank 1 is going to select. If this one is 1, if this one is 1 and this one is 0, then bank 2 is going to select. If both are 1, if both are 1, if both are 1, 1, then bank 3 is going to select. So how we are going to choose the bank register? Then we are going to program or set the bit of PSW like this. So according to this, the particular bank is going to be selected. If any one of the registered bank is not selected, then the programmer can use the area from 00H to 01HF as simple scratchpad RAM or general purpose RAM. If we have not selected any particular bank of the register for our use case, then generally programmer always use from 00H to 1FH as general purpose RAM. Upon power on or reset register, bank 0 is going to selected by the default. Once power is off or reset, the register bank 0 is selected by the default. Some disadvantages of this also. We know that the register bank 1 use the same RAM space as the stack, and this is a major problem. While programming 8051, we must either not use the register bank 1 or allocate other area of the RAM for the stack. Always the register bank for the stack, the bank 1 is used. If generally we are using bank 1, then both conflict will be happen gather because the same memory is using for the stack memory and our working area is also bank 1, then this is one of the disadvantages. We cannot use like this. Generally the bank 1 is used for the stack. And advantages of the registered bank is the advantage of registered bank, that is the reduce the latency period for the subroutine call or an interrupt. When programmer is using a set or a reset, when programmer using the set of the register R0 to R7 of the bank 0 and an interrupt occurs for normal process, the interrupt service routine or subroutine begins with the pushing the contents of all the registers onto the stack. This avoids overwriting of the data of circular function at the end of an interrupt service routine or subroutine all the content of this register are to be popped. And this pushing and popping the data in the extra work the processor has to do, the time required to do this is called as a latency period. In case of 8051, the programmer need not to push the data when an interrupt occurs or when the subroutine is called. Instead, the programmer can switch other set of the register, and hence the programmer need not even pop the data from the stack. This saves the latency period and hence improve the efficiency of the system. So how we can going to set the register by using an instruction? Let's see now. These are some instructions. By using this instruction, we are going to select the register bank. Those are set ESW.3, clear PSW. So using this, by executing this instruction, the PSW set the PSW.3 is nothing but third position of PSW is going to set is nothing but it will become 1, and clear is nothing but this one is become 0. Clear. Then this is become 0-1 combination. 0-1 combination is nothing but bank 0 is going to select. Sorry, bank 1 is going to select. By executing this instruction, bank 1 is going to select. If both are clear, if both are mid 0-0, if both are 0-0, then bank 0 is going to select. If this is 0-1, this can made 1 by writing set. Set this bit is nothing but 0-1 is nothing but this one is, this combination become, what combination will become here? 1-0. 1-0 combination is nothing but here fourth bit of PSW is 1 and this one is 0. Then hence this will become bank 2 is going to select. Bank 2 is going to select. If I want to select bank 3, then what can I do here? How we can select bank 3? I have to set both the bits of PSW. Set both the bit, then what combination will become here? 1-1 combination will become 1-1 is nothing but bank 3 is going to be select. This is the process of selecting the register bank by executing the instruction. Now let's see bit addressable area. This bit addressable area of the memory organization. The size and address of this range is, the range of this bit addressable area is starting, size is address is starting from 20H to 2FH, and which is how it is some 16 byte of internal RAM, which is having 16 byte of the internal RAM. Byte, which is having 16 byte of the internal RAM, whose address ranges from 20H to 2FH. These 16 byte provides us with 16 into 8, that is equal to 128 byte, forming addressable bits. So the microcontroller has given addresses to these bit ranging from 0 to 127 or 00 to 7FH. Hence, these locations are called as bit addressable locations as shown in figure. The addressable bits are useful if the binary event in the program need to be remembered, and open switch, close switch operation is also going to perform. In order to access the 128 bit of the RAM location, the other bit addressable space of 8051, we can use only the single bit instructions. All the single bit instructions support only the direct addressing mode. For single bit instruction, there is no indirect addressing modes are there. In general purpose RAM, the RAM area is also called as cracked area. It lies above the bit addressable area and has addressed up to 38 to 7FI. And this RAM area can be used as data RAM, and the memory in this area is a byte addressable. The programmer may declare stack in this area provided the sufficient number of the bytes are available. What are the uses of internal RAM? It is not essential to utilize the entire area of the RAM of the microcontroller scratchpad. The microcontroller has instructions that allow the internal memory location to be used as a data pointer. The register R0 to R1 in the 4 register bank, that's bank B0 to bank 3, can be used as a pointer to point the internal RAM as well as the external RAM. When the register R0 to R1 are used to access the external RAM, these 8 bit will be used treated as LSB of 16 addressable, and MSB is taken to be 00H by the default. This is the organization of the internal RAM. Now let's see the external memory. The external memory used in case when the internal ROM and RAM memory available on the chip is not sufficient. Two separate external memory space are made available by the 16-bit PC and DPTR, and they are different control pins for enabling the external ROM and RAM chips. The 128 byte of the internal RAM is insufficient, then external RAM is accessed by the DPTR. In the 8051 family, external RAM up to 64 kilobyte can be added to the any chip. The external ROM of up to 64 kilobyte can be added to the both both 64 kilobyte of external RAM can be added to the chip. Now see the special function register, are also called a special purpose register. The special function registers are placed in the address space immediately above the 128 byte of the RAM and from addresses 80H to FFH. The special function register memory consists of important register like accumulator, register B, interrupts control registers, ESW, timer and counter, power control, 4 I/O ports, serial control. Some of these registers are bit addressable, while remaining are byte addressable. Okay. These registers are some of the bit addressable and some of the byte addressable. These register contains like a register B, accumulator, PSW, IP, and these things DPTR. In the DPTR, they are data pointer itself having DPL and DPH, which is having memory address like this. Some of the address location in between ETH to FFH are not used. If we try to use one of these unused location, then are not defined or are empty. When we may get unpredictable result, when reading from such a unused location, a random data will be given. When writing the data, such unused location, the data will be lost or not stored anywhere. The PC is not a part of the SFR program counter. Here the program counter is not a part of the SFR. The program counter does not have any internal RAM address. The special function registers are preferred by their address such as 0EH, 87H and 90H like this. The registers from the special function registers are addressed. These are the some special function registers. So today we have seen the whole memory organization. Both are internal and external, and some special function registers, function register memory we have also seen in this